A particle is projected vertically up from the foot of the tower 392 meters high with a velocity 98 meters per second. That is, at the same instant, another body is dropped from the top. Find when and where they will meet. So we have when and where they will meet. By when, we're simply talking about the time. And where, simply looking at what position are they going to meet, that is the distance. So let us calculate the two, time and distance. Now here we need to look at the height of this same tower that we have. So this particle, the first particle, is projected up from the foot of the tower, which is simply 392 meters high. Okay, 392 meters high. And now one that you also need to note is that the two particles are meeting. The first particle is meeting with the second particle, so we'll let them meet. We'll let the first particle meet the second particle at y. Yes, so we'll let the first particle meet the second particle at y. And one thing to know is that the first particle is moving at a speed of 98 meters per second. So the second particle will simply have okay, we're letting the first particle meet the second one at y. Now what will happen is that the distance of the second particle in this case now will simply be equal to the height of the tower minus the value of y. So it will mean that the distance of the second particle will simply be equal to the height of the tower, which is 392. Then you subtract a y from there. Okay, 392 minus y. So let's see how we go about it. So we're going to write for the first particle. We first calculate the values for the first particle. So that first particle, say particle 1. Now particle 1 is moving at a speed of 98 meters per second. That is the initial speed of particle 1. So the initial speed of particle 1 is 98 meters per second. Now this is how you calculate distance, like that, half AT squared. Now s in this case will be the distance for particle A, which is a y, where particle 2 is meeting particle 1. So y is equals to ut. Now since it's opposing the direction of gravity, has been minus half gt squared. Thus we get our y will be equal to, initial speed is 98 meters per second, the one that is there in the question. So I have 98 meters per second. We don't know what time is, so just say t, then minus half, g is 9.8, then this has to multiply with t squared. So this further simplifies to y is equals to 98t minus 4.9t squared upon dividing 9.8 by 2. Okay, like this. Then this will be labeled as equation 1. Now we move to the second particle, particle 2. So this one is being dropped from the tower. So here we have that displacement is equals to s equals to ut plus half at squared. We have that the distance for this one is simply 392 minus y, as clearly indicated there. So put 392 minus y. Now the initial speed, this one is starting from 0. It was at rest initially, so there will get a 0. Then this will just give us half gt squared. So it should be 392 minus y equals to that is g, then half g, 9.8, then t squared. So this will give us 392 minus y equals to 4.9 t squared. Equation 2. Now what you do from here is you're going to add the two equations together, equation 1 and equation 2, so that we find y and t. Now here what you do is, when you're adding equations, the way you add them is you add the left hand sides together, then you equate with the sum of what you have on the right hand side. So let us add the left hand side of the first equation and the second equation. So this is 392 minus y, then you add with the first equation, which is y, as you can see there. Now what happens, since these y's have different signs, this is for the left hand side, they will cancel, they'll give us a 0, remaining with 392 on our left hand side. We now proceed to the right hand side. So right hand side of the first equation is 98t minus 4.9t squared. So that's what we have for the first equation. Then you add with the one for second equation. Oh, sorry, that was not supposed to be negative. That is supposed to be positive because this is moving in the same direction as gravity. So it's plus 4.9. So remove that negative there. Sorry for that error. So you have 4.9t squared. Now, the 4.9t positive and the negative will cancel because they are the same, leaving us with 98t on the right hand side. So now we equate the two sides. Left hand side, which is 392, to the right hand side, which is 98. So equating the left hand side to the right hand side. So we have 392 equal to 98t. Now here divide both sides by 98 so that you solve for t. So this therefore gives us our t to be equal to 4 seconds. When they meet, the answer is 4 seconds. So they are meeting at 4 seconds. Now let us find where they meet, and that is just solving for y, and that is in the first equation that we generated there. So to find where they meet, we look at the equation, the first equation that we generated, which is the value of y, since that's where the two particles are meeting, and that is what we're going to simply have. Meeting at y, which is equal to 98t minus 4.9t squared. Now, however, the still are going to substitute with the 4. So it will be 98 times 4 minus 4.9, then 4 squared. The first part gives us 392. Then minus the second one will give us 78.4. Giving us our final answer as 313.6. Sorry, it's 313.6. So they meet at 313.6